Robotics open mic event. Bring Your Own Bots, BYOB. My name is Gina. I'm a volunteer for Women in Robotics Boston, and I want to thank Darini and Sangjuksha for this wonderful opportunity. I'm really excited for tonight's presentations and discussions. So everyone can introduce themselves in the chat. Make sure to drop your LinkedIn if you'd like to, so we can all connect afterwards. And a little bit about us. So Women in Robotics started as a grassroots community to support women in robotics across the globe. Now it's a nonprofit organization, which was founded by Andrew Kay at Silicon Valley Robotics in California. And this is the Boston chapter of Women in Robotics. Currently, we have 150 members in our chapter and a little over 1,600 in our global community. Anyone from a professional background who supports our cause is welcome to join our group, and the sign-up links and other resources will be in our chat. So please do check it out and join our communities if you haven't already. And we also want to thank our Zoom sponsors, Beckner Robotics, for their continued support. And throughout this event, we aim to bring the opportunity for attendees to show their thesis, a project, an idea within robotics and AI, so that they can have some exposure, recognition, and then great feedback from our supportive community. So we're gonna go off to the presentations now. First, we have Kritika, who will be bringing her project, Unblock Interactive Perception for Decluttering. So if you're ready to present, you can share your screen, and we're really excited to see it.
Sure. So I'm just going to share my screen. Yep. Can everybody see my screen? Right. Okay. So I'm Kritika Govindraj. I'm a research assistant at the University of Maryland. And today I'm going to be presenting my thesis on interactive perception for decluttering. So the premise of this thesis is to ensure that there's a human-like decision-making for decluttering the scene, especially for static scenes where the objects are not moving. It's very hard for novel segmentation algorithms to find objects in such type of scenes. So that is the motivation behind this thesis. So here are some results. And just to emphasize on the need for this research, you can see that with the changing of the camera angle, different number of objects are detected each time. There's no consistency in the number of objects or the type of objects that are identified. So I'm using YOLO. I've also used Detectron True, and I found that these are the same results. They're not giving us accurate results. So we need something that would remove or declutter the scene before we apply these techniques. So how does a human identify their scene? How does the human explore the scene? So we try to move things around, we try to push things around, we try to explore the scene by making changes in the environment, basically. So this is the novelty, is that we are trying to address the drawbacks of novel segmentation techniques. We are designing our own custom reward signal for decluttering the scene, as well as we are using mid-level vision instead of using images themselves. So the whole system is designed using Majuko. It uses a 7-degree of freedom fetch arm, and we have added different types of objects within the scene for decluttering. So how do we enforce human-like behavior? So the closest that we come using for human-like behavior is using reinforcement learning. So unlike humans, reinforcement learning basically uses trial and error. That is the biggest difference. And there are basically different types of algorithms that try to combat this drawback from reinforcement learning, but this is the state of the art in trying to learn through experience. So we chose this, this approach. So through a good balance of exploration and exploitation, humans can make decisions, and that's what we are trying to emphasize. So this is a little bit on the actions and observations of our environment. Won't get into much detail on this. But essentially, all of the arm can basically move in X, Y, Z, and the gripper can move, can open and close. So let me just get into the network design, right? So there are basically 3 networks that are involved in this thesis. So the primary one is the one that you see on your bottom right-hand corner, is the holistic edge detection network. It essentially decides the number of edges in the image. And this number of edges is fed into the reward signal, which is fed directly into the environment. And the reinforcement learning takes place using a DDPG-based active critic network. And there is a Hindsight experience replay memory buffer, which essentially stores all the experiences. And we'll get into more detail on these three networks in our next few slides. So mid-level vision. So why do we pick mid-level vision? For our application, we are trying to declutter the scene, and we know that there can be partial occlusion and there can be full occlusion. So during partial occlusion or full occlusion, we need to find the number of edges. We obviously can't find the entire object. So the only data we have is the number of edges, right? So there are two approaches to this, one using an image torque, another one is using a machine learning based algorithm. And we've decided to go with the machine learning based algorithm due to scale invariance. So a little bit more on the holistic edge detection network. It basically is trained on the Berkeley segmentation data set. It uses a VGG-like network. And the reason why it's scale invariant is because after each of the convolution layer, the result is fed directly into the output, which so essentially the scaling is handled within the network. So these are some of the experiments. So this experiment is just to see what is the size of the image we need to feed into my system. And it is found that the 360 cross 420 is the ideal size because it's able to find the largest number of contours. This is how the YOLO basically looks. This is just a video on, I'm trying to show that, by moving the camera, the number of objects detected is pretty bad. And it just varies inconsistent, and there's a lot of inconsistency in that. But if you look at the edges, right, and you can see that there's consistency in the edges in the scene. So that is that, and when we remove an object, you can detect more edges. So that is basically how you can, declutter a scene. Essentially, I'm going through all the different types of networks, and there are two types of reinforcement learning-based policies. There's an off policy and an on policy. I'm just trying to emphasize why we are using an off policy and why we require DDPG with a hindsight experience replay. And that is evident by the graph that with the hindsight experience replay, it works better. These are just some results. Again, emphasizing that DDPG with hindsight experience replay is the best approach. So a little bit more on hindsight experience replay. So the way that humans learn from experience is through recollection, right? We store our experiences and we are trying to output, we try to go back to these experiences and learn from our mistakes. So that's why hindsight experience replay works best. So this is one of the very few buffers that can learn from failures. And it works best for our case because our case is more like a chess game. So until the end of all the actions, you won't know whether the scene is decluttered. That is because the arm has to move a couple of, through a couple of iterations to push objects around. And then it's very similar to a chess game where you have to move pawns around until you won or lost the game. So the way that researchers approached this problem was by making the reward dense or using this sort of a replay buffer which can learn from mistakes. So this is why we have decided to go ahead with this type of a buffer. Again, there are different modes, and I'm just trying to emphasize that the mode called future is the best for our application. Again, the buffer size, which is used for these replay buffers, also plays a huge role. And I'm just trying to emphasize that using a buffer size of 1,000 is the best for our application. So we're trying to structure the reward in this. And as you can see, initially, we are just using the current number of contours, and we're trying to just tell the system to increase the number of contours per iteration. And simply using that, this is the result, right? The arm is moving away from the object. Essentially, it's not able to hit anything. So how do we make this more dense? How do we emphasize to the arm to move towards objects? So we basically need to take into consideration not only the increase in the number of contours per iteration, but also we need to emphasize on having the arm stay near the table. So that is done by the assumption of a depth sensor. So I'm assuming that there's a depth sensor and it can find all the objects that are less than 0.1 meters away from the arm. And it gives it a reward for that. So I'm trying to make the reward more denser instead of sparse. And I'm also emphasizing for the need for the number of contours to overall increase after all the epochs have completed. So let's see how this works. So it's able to hit the object now, but then again, we're not able to get more accurate results. And this is because of the scaling factor. So as you can see, I'm trying to round all of these rewards up to 1. And this video is essentially sped up by 4 times. So the arm is moving very slow. So how do we speed up this arm? So I found that by using integer values to scale the reward gives us a better result. So the most important part of all this was, trying to have the arm explore. So Hindsight experience the replay brings about convergence quicker than it should. So what was happening was that the arm was learning incorrect actions because it would converge to a value and never explore. So how do we force this arm to explore as well as, come to a proper convergence? So there are 2 ways of doing this. Prior systems used epsilon greedy method, and now we are trying to use a noisy net-based approach. It's again a machine learning approach where we're inducing Gaussian noise. So this is essentially the description of the network. There are 2 ways that you can introduce noise. One is a factored Gaussian noise, and another one is an independent Gaussian noise. And both of this depends on the type of network we use. So the conclusion is that we're using an independent noise, basically, because it's an actor-critic network. So I'm just trying to emphasize here that with no noise, the total number of rewards is lesser than with the noise. This is, again, changes in the observation, desired goal, and achieved goal. So the way that the arm works is by trying to move towards these objects, right? As we saw in the previous few slides. So I started off with just giving the position of the object and the gripper, and by not feeding it the number of contours. So one of the parameters that I found which really improved the learning was including the number of contours that were detected. So this was the final observation goal structure for the system. So here are the final results. This is a really decluttered scene. It's trying to move towards the area with the most amount of clutter. And you can see essentially what the system is seeing. You can see the number of edges that are spotted using the network. So it's essentially trying to push the object. So you could see that the blue object that it's trying to hit, it was actually hidden in the scene. Now it's now you can see it more clearer. And this is one other result. So you can see that the arm has explored the scene properly because it's able to take proper actions. It's moving in different directions. It's not just moving in one particular direction. So the conclusion of this research is just this. Essentially, action is very vital to static scenes because there is no movement unless you induce a movement into the scene. The novelty is to use information derived from images instead of using entire images. We are also changing the observation and goals, which are crucial for successful learning. And the Hindsight experience replay is also crucial for enabling learning from failure because our rewards are very sparse. And noisy net-based exploration also allows more actions to be explored accurately. So the future work for this would probably be to implement it on hardware. So we would use domain randomization, transfer learning, probably use ROS instead of Majuko and OpenAI. And yep, that's about my thesis. Thank you very much.
That was wonderful. Thank you so much, Kritika, for sharing, and what an interesting project. So I think we'll open up for some Q&A and comments. I think Sanjuksha has a couple first, and then we'll open it up to the rest of the audience.
Sure.
Thank you, Gianna, and Kritika, wonderful presentation. So you actually like combined reinforcement learning with like machine learning. Is that, am I understanding that correctly?
Yeah, it's used.
That's really great, actually. I mean, I have learned about both of them, and combining the both of them is really nice. So I saw like the reward system and are like based on the number of contour edges that you said. And
yeah. So let me just go to that slide. So could you reiterate your question again?
Yeah, so my question actually is like how fast is the learning, and what did you do to like improve the learning rate?
Oh, okay. Yeah, the hyperparameter tuning. Yeah, so I would say I had to train it for like 50 epochs, and I think the training really depended on the learning rate for the actor and the critic. So I needed to place, I think the learning rate was 10 to the power -4 for like the Adam optimizer or something. So I think both of those needed to be tuned up. It was so there needed to be a balance, because what the actor is trying to do is explore the scene, and the critic is trying to critique what the actor is looking at. So I think both those learning rates needed to be the same. That was one improvement. Another improvement was, again, scaling this the image. As I said, the holistic edge detection, the image needed to be scaled appropriately so that I could detect as many contours as possible. And then I think the number of epochs as well played an important role, right? So if you train it more, it gets overfit. So you needed to train it lesser, give it more data. So those were the tuning parameters that I did. So yeah, I hope that answers your question. Yeah,
it does. And just out of curiosity, like how much time did you take for like the whole training part? Because it's like networks, so.
And I would say I have a really slow computer, so it took like a day. But probably if you have like a very good computer, I think maybe it would take maybe 3 hours or so. Yeah.
Wow, I was expecting that. I mean, that's definitely it. Thank you. That's all I have. Thank you so much, and wonderful presentation.
Thank you.
Thank you. Okay, so do anyone else have any questions, comments, feedback?
I kind of have I don't have a question, I just have a comment. First of all, this is a really interesting project, and I think it has a lot of direct applications. One of the I actually have I came across a garbage separating application. It's an actual company in Boston, and I think there are like even in pick and place kind of applications, this project will be very, very much applicable. Maybe like I don't remember the name of the company, but I'll check that for you if you are interested in contacting them. Secondly, it will be very helpful if you can easily transfer your work to hardware. So since you've already mentioned for future work that you'll be trying to use ROS, that'll be helpful to directly transfer it to hardware if you use Gazebo or something like that. But what are you gonna be working on this project further, or your thesis is over?
My thesis is over, so I'm not going to be. Hopefully I get a chance to work on it, but yeah, it's over for now.
Okay, so if you're looking for a job or something, I'll definitely suggest you to like look into those companies, because they'll like directly be absorbing you, because this is directly applicable to what they're doing. Yeah,
that's great.
Are you talking about Soft Robotics? Is that company?
No, they were kind of separating recyclables from the garbage, that kind of thing. I'll check the name and definitely get back.
Okay, yeah, I'll look forward to your email. Yeah.
Wonderful. Anything else from our audience, I just want to say this has been a great learning experience. I look forward to learning more and maybe chatting afterwards just to hear all the cool details.
Yeah, sure.
Cool. Yep. Awesome. Okay, well, we'll kick it off now with Eltonai, and thank you also for your wonderful presentation. I think we're all excited. So I think let's see, perfect. If we can get screen sharing going. And if anyone else has a presentation that they'd like to share, just drop in the chat project name, and then towards the end, we'll definitely have time if anyone else would like to share.
So I start sharing my screen now?
Yes, that'd be perfect.
Okay. Let's go. All right. Hello, everyone. My name is Eltonai. I am going to be presenting a robot that I started off as a hobby project a while ago, and how it has matured over the years. So what essentially I have here is a robot to clean roads. So it's basically a robot that identifies garbage and picks it up. And yeah, these are some of the versions I made over time. There are few more, but at the moment I had 3 here. So a little about myself. I am pursuing master's at Seattle University. I have a decade-long experience working with telco softwares. And I have authored a book on WebRTC. WebRTC is a technology that I have also heavily used in my project, which I'd show in a while. So the problem. So what is the problem? Problem is a lot of litter along the roads, in lanes, in gullies. So it's just so small pieces, right? It's like a wrapper or a plastic cup. Off the lane, there are masks, you just see them. So they are kind of like biohazards. So a robot that kind of targets these small garbage objects. All right. So we've seen a lot of examples. Yeah, so this was the initial goal I started with. So there are 3 brush assembly system. The garbage that I'm targeting is light enough that it can be lifted easily with these thick bristle brushes, okay, because they are rotating clockwise and anti-clockwise, and then the top brush kind of just nudges it inwards, so it falls into the tray. So with that basic assembly, I kind of designed other things that go along, the tray, the bin, the Raspberry Pi to keep in touch, real-time streaming system, so we can actually decide whether we want to go in that direction, pick up that garbage. That was the initial manual system that I kind of designed with a real-time streaming. And this is how it looked. And I could just quickly show you in operation. So like that. Okay, but this is, of course, manually controlled. Right? And then with that, I kind of, with some more iterations, I reached to a point where I thought that the batteries were actually recyclable motorcycle batteries, and they used to only last for 20 minutes. So, but then it was better to use solar energy directly. And that is when I made some upgrades, made it more autonomous, and replaced it with a panel on top. So the design was a little difficult because the robot and the motors have to go along carrying the weight of the panel and everything on it, and at a average sunny day. So I had to trim the panel, take out, like to make it further light over the time, I had to take out this aluminum casing and make and remove some of the other sensory components that I would have wanted otherwise. So this is how it looks now. And it works. And yeah, some of the things that I would like to see in future is reinforcement learning, like Kritika before me was explaining, to maximize the gains. I would actually like it to have the depth sensing. This is a type of sensing and stereoscopic vision, so I can better identify the garbage that I'm going towards. Just a quick glance at so this is actually the component that I was talking about earlier, the WebRTC streaming. So that's very important because I don't want all the heavy, garbage detection work to be on the Raspberry Pi, because earlier I tried doing that with OpenCV and HAR and Cascade models, and it was very heavy. It was very difficult to upgrade if I want to add something new or push an update. So it was better that I stream the feed from the cameras on the Raspberry Pis to a cloud system and do my processing there, and then send back the instructions on a peer-to-peer system. So like I said, initially when I was not using solar panel, I had the luxury to use as many communication modules and sensors. So I had BLE there, Wi-Fi there, dongle there. But then now I have a very lean and thin system to optimize my power. So it's just a real-time streaming and some object detection and garbage tracking, and the response goes back to the robot, and it mostly function in an autonomous way. So basically it has 3 units, a driving unit, cleaning unit, and a body. And this is the side and the top view, and regular things that you would find in any small scale robot, Raspberry Pi with its modules. This was the concept that I had in mind many years ago, and this is the realization. This one is kind of cool. It exactly looks like how I had thought of it to be. And this is the messy back assembly. Since I am not actually from robotics or electronics, this is the best I could do. I'm a software engineer, but I promise I'll do better in there. So this is an very high level diagram. And yeah, and this part you've already seen. So this, yeah, and yep, and there are some detailed slides later on, but I'd actually like to hear from everyone now. I'm opening it for discussion.
That was wonderful and such a great project. I think hopefully one day we'll see those everywhere, just along the streets, and it could be a more worldwide or global type thing. So that was wonderful. I think, does anyone have any initial questions or comments? I know you have a couple of slides you could go into more detail with. So if anyone has any particular areas, that would be great.
Yeah, I actually love the part, like you showed how much it has come so far. So like, congratulations, first of all. It's a really nice product. I mean, and good thinking about the whole, like, I like the mechanism as well, because it was so quick and so easy to look. Like, it's not very complicated. So I'm pretty sure it works awesome. And again, like, I liked your presentation a lot. It was so awesome to like see the entire thing. You talked a lot about WebRTC, and you said you have a book on that. I mean, I'm not really familiar. Could you like give like a small explanation about what it is and what it's used for exactly?
I'd love to. So WebRTC has kind of revolutionized the software communication landscape in a way. So we know that earlier when there was 3rd generation and 2nd generation of telecom, it used different underlying network. But now with internet protocol, everything is kind of like merging towards a single backbone network. So whether it be IoT, whether it be telecommunications and other kind of publisher notification systems, so they are all coming on the backbone of IP. So similarly, WebRTC kind of does a peer-to-peer. It's specifically designed for peer-to-peer media streaming. So it's a real-time, lightweight media streaming on royalty-free codecs. It's a standardized technology from W3C IETF, and it was initially supported by Google and Mozilla, and now it's on all the mobile browsers, on the actual browsers. It also is it's a driver. Actually, the codecs are can be add on to Raspberry Pi, and Raspberry Pi can directly stream WebRTC stream to any peer that's connected to. We of course have to design our own signaling server, because for a point-to-point media to flow, we need to know the exact IP and port. So for that small handshake purposes, there has to be a signaling server somewhere accessible publicly. But yeah, WebRTC is great. So it basically allows me to manipulate the media stream in any which way I want on the cloud. So my Raspberry Pi stays very, very light.
Yeah, that's like the main purpose, right? I mean, I've heard about Intel sticks and everything doing the processing like on the outside and then getting it on the board. So I think this is like a real-time processing.
Yeah.
That's awesome.
Yes.
I'm just curious, is this like your master's project or like?
No, this is a hobby. No.
Wow, this looks like it's like closer to being like a full-on product, like in the robotics. So I mean.
Well, I do like to work on it in my weekends and whenever I have some free time. It's a self-funded open source project, and a large part of it is actually help from people from multiple disciplines. So someone came along and said, oh, why don't you use solar power? You'd not have to recharge your batteries after every 20 minutes. So I did that. And somebody then came along and said, okay, this particular sensor will do better than the previous sensor you were using. So I did that. And that's how I've actually gone to few places and I've received good response. There's Grace Hopper. And since it's a very simple robot, I often take it to these school events and showcase it there, and some okay-ish events like this open source event. So that's all I do with it at the moment. I'm kind of hoping for it to be autonomous enough that it doesn't make mistakes, because right now I see that it kind of misses identifying some garbage and just keeps going on its track. So what I would ideally want it to do is to identify the garbage and go towards it and then come back on track. So I'm actually open to suggestions on that, but I'm still working on it.
Yeah, it's really great. I mean, I just want to say that it has a lot of potential to like become a proper commercial product. So definitely, good luck with that. All the best. And as you said, if you like suggestions and already like, I would say that you should join the Slack community if you haven't already. I am. Yeah. So yeah, just post it out there. I mean, I guess our audience from today also can help with that. But yeah, definitely post it there.
All right.
I have a couple of comments. First, really, really clever idea. I love your passion, and I love the part on the name as well. So that's really cool. Is it? Are you intending it? Like,
yeah.
That's really cool. So for those who don't know, so Ramudroid is like, Ramu is something like we call a servant or usually a servant name. That's what, anyway. Yeah. And I mean, that's really passionate that have you like thought about it. And so a lot of times, like being engineers, we see something and we like, okay, yeah, we can solve that, but we never try to, make something out of it. So I'm really inspiring. And if like, I was actually going to suggest that you put the project in some competitions, but since you've already like did some outreach, so that's great. If one question I have is, can by using the WebRTC, so you mentioned it is a peer-to-peer network, can we have like a group of these robots and like covering a large area, and maybe we can try to make a swarm out of it and assign some areas to, a group of robots to do it? Will the streaming platform be able to handle that? And what changes would you have to make on like, because since it is not decided on the RPi, so you kind of have to do everything on a server. What changes would you have to make for that?
That's an excellent suggestion. That would also be something that I would like to pursue in my future. So WebRTC is a very lightweight and involving technology. So we could definitely have a central cloud server catering to the live feed from multiple robots, or even robots and drones and wall-mounted cameras to detect garbage and litter. So once the model is trained enough, it could actually detect garbage and signal the robot to go and pick it up. Yeah, but that would actually, from the WebRTC end, it's very easy. Actually, the mesh-based conferencing systems are already in right now. Had we taken the Zoom call from a web browser, we would have used WebRTC automatically. It's that popular, it's that common. So it supports at least up to 20 simultaneous streams is something very easy for WebRTC. To take it a notch beyond that, like maybe have a 50 participant or 50 real-time streams, we would have to reduce the resolution of individual streams so that the mesh network doesn't get congested and there's no lag. That's there. It could handle multiple streams. For the sync specifically, we'd probably have to ensure that every robot, every drone that's streaming to that centralized cloud server, which is actually doing this object detection, doesn't have a lag. But that can be adjusted.
Yeah, that's something. Yeah, that's what actually I was like kind of asking. So once you have all that input, you'll need to like have some sort of a hybrid decision making algorithm to tell what each and every robot what to do and kind of separate those detected objects out. But I think this is a completely different problem statement. Like, even if you don't work there, there'll be somebody else who is working and you can like collaborate with them.
Absolutely.
So this definitely like has potential to turn into a product. One suggestion I have on your presentation is that be more confident with this. Don't try to be modest. You're doing great work. No need to say that like it's like the best that you could. This is really great. And what you need is essentially more collaborators. It's great that you already have a GitHub framework and you have uploaded it on it and portraying it as already as an open source project. Maybe you can try to add kind of a pitch for engineers to help you work on it. If there is anything we can do, let us know on that part. And that's all I have.
Awesome, thank you. Yep, that's it. I'll stop sharing.
That's great feedback too. And I just want to reiterate, I think for either of our presenters, if the Women in Robotics community can help at all or provide any collaboration opportunities, then I think that's a great next step. And do either of our audience members have any questions, comments? You can also throw them in the chat too. Alrighty, if not, I think we can open up for robotics AI discussion if we'd like to. If we want to have any discussion around collaboration for either of our presenters' projects, that's open too. This is kind of your space, community time. So whatever anyone would like to do for the next few minutes or so, this is open time.
If you have time, I have one more question for Altania. So do you have any like plans or prospects about taking this further?
Of course, I think this is something I'm really proud of. As long as I can, I would really keep building on top of what is done. And like Dharni said, community support is something that I actually would like on that, because I cannot really solve some of the mechanical problems myself, some of the electrical problems myself. Especially around the power management, because now that I have renewable energy in scene. So yeah.
That's perfect. Yeah. I mean, I personally am really interested in this project, and I would probably like contact you later to talk more about this.
Of course.
I mean, solar power in general, like we basically have the whole big battery problem in robotics. So if you're like keeping it charging all the time, it's like the perfect solution. So yeah, I mean, like the particularly solar power idea.
Yeah, Altani, I was just gonna say, if you need some help with reinforcement learning, I'm all in, because I have some experience. I think that'll help.
I would actually really appreciate that, because I have tried training my own models. I've tried using the Google's teachable machines. I've tried using the IBM's version, and I've tried doing it myself. And there's always, I'm not able to beat that 60 to 70% mark, because the garbage comes in all forms of shapes and sizes. It could be a broken glass, it could be a crumpled paper. It does not detect, I feel, most of the time. So I would really need like some help in that direction.
Yeah,
That would be really
for sure.
nice.
Yeah, for sure.
What are your training on, like, for the inputs?
I have downloaded multiple data sets. There were some research papers for these vehicles that detect trash bags actually and overflowing bins. So I use their data sets. I have also collected my own data sets over the years with creating my own garbage essentially around my house to take multiple photos. So I have a fairly okay amount of data in data sets, ranges between 10 to 12,000 images of various types.
And how long have you been doing this? I mean, the whole project, when you start?
On and off, it's been 5 years, but then I don't really continuously work on it all the time. So it's a couple of weekends in a month. Yeah.
So if I'm not wrong, you're using some sort of an object segmentation detection sort of a network, and you're having it move towards that object, basically.
I didn't really understand your question. I could actually show you some, like, can I share screen again?
Yeah, sure.
Okay. So I kind of summarized my findings here. So the initial approaches that didn't work because they were not enough. Then other approaches, some of the available models that I used, which wasn't really detecting garbage, it was more interested in detecting people and vehicles. So it's definitely not working for me. Some of the other models which achieved good results in isolation, but they don't really achieve good results when the garbage is clustered. So, but if I kind of place them far away like this and from a certain angle, then it's good. But then once it's approaching like this, because it's at a ground level, the robot is not too tall, it doesn't work that well. So this is basically what I have tried. I think it could be put in the transfer learning category. I'm not sure.
Yeah, I guess here Kritika's whole reinforcement learning would come into play, where you can give the camera the positions to like actually try and detect it.
Yeah.
So
yeah.
Since you both are here, it's like a great coincidence that you guys can collaborate in future. Like both the projects are so something that have potential for collaboration.
Yeah,
so nice.
Yeah, I would really. I've actually sent Kritika a request on LinkedIn. I would really like to learn a few things.
Yeah, we can definitely collaborate on this for sure. Yeah.
How do you like control the robot for moving? Like, do you have? Like,
it does it by itself. I can also manually override it because it takes the Raspberry Pi kind of takes input over the cloud, over the peer-to-peer stream, the P2P stream that I've set up. So WebRTC also has data channel support. And with that, I can, it also has REST API support, but REST API I figured was a little slow. So this P2P WebSocket based system is much faster. It can also do that, but it kind of it does it by itself unless it detects an obstruction, it keeps moving.
But my question was a little bit different than that actually. Like, do you have like a control algorithm, or how do you plan your motion basically?
It's mostly straight until it sees an obstruction. It then turns a little and then it continues going straight till it sees an obstruction. There also is a GPS location coordinate that I give it. So it tries to go in that position. That area also has some work that is left to be done, but given a straight lane or a semi straight road, it manages by itself and avoids obstructions.
Oh, so basically you do have obstacle avoidance and all that as well.
Yeah, it does. It basically avoids walls bumping into walls and other obstructions. So that part is there because that it detects that as a obstruction. Earlier, I was using the two camera thing. I forgot the name. It's called ultrasonic, I guess.
Ultrasonic sensors, yeah.
Yes, ultrasonic sensors. So they were piking. But now I have kind of, since I'm running on a constraint system, I do most of my things based on the camera vision.
Oh,
That's perfect.
I don't think you need to like do these things which are not related. So so the main thing I'm saying, like focus on the detection of garbage and picking up mechanism. So you can, the autonomous moving part of it, you can already find like either if you get some investment, you can just like buy a autonomous robot and put your stuff on it, or just like try to use ROS, maybe, because there will be a lot of libraries to detect like do the autonomous stuff for you, so you don't have to worry about that. So that's, but yeah, I mean, I understand it'll be like another investment kind of thing, but that can be one of the priorities.
Sure, yeah, of course. ROS is something that I am actually hoping to integrate, because the Raspbian thing, it has some limitations clearly. So yeah, that's a good direction.
I can help with that. I mean, yeah, I'll ping you for sure.
Sure, awesome.
I'm not actually like more familiar with the boards, but I'm sure you can do like something better than Raspberry Pi as well. So I mean,
for a hobby project, Raspberry Pi is good.
Yeah, I mean,
if you have like a little bit more of investment. I know autonomous robot called Firebird. I don't know how much it costs, but it's I used it for a competition back in my undergrad, and that's pretty good. You can just like put stuff on it, and then yeah, it works like it'll.
All right, thanks.
Cool. Well, it sounds like we have some budding conversations and collaboration, which is always nice. I think that's the best part of this community, at least also what I've kind of gotten from Women in Robotics so far, is just everyone's very open to helping and just like having conversations, which it's nice when you don't always have those in such like a technical space sometimes. So it's been great.